Feel free to unmute yourself if you want to talk, or if you want to type it into the chat, that's fine as well. Okay, so it is 7:30 your time, 8:30 my time. Just so everyone's aware, what we will be doing is we will have live lectures at 7:30 your time. Um, every single Monday, unless for some reason it's a holiday or if the campus closes, then we would move it to another night. But I believe we should be good with everything. I see a few of you guys entering your name into the chat. That is not necessary. What we do, or what I do, is at the end of the lecture, and it's important that you pay attention and that you're actually here and that you don't just, sign on and walk away. But at the end of the lecture, I'm going to give you guys a code word that you'll put into an assignment to get credit. Now, if for some reason you're not able to attend, um, all of the clinical sites should allow you guys to step away to attend any of the lectures. However, say there's an interesting case or something's coming in that you really, you want to comp on, or that you want to see, or say you've got an appointment that you've got to be at, it's fine. However, what you would do is you would watch the live lecture and then you'll write a summary to review everything. But we'll go over that in a second. I just saw a few of you guys writing your name in and wanted to make sure that you guys were aware that you do need to sit and actually watch the live lecture. Now, I have been with CHCP for almost 10 years now. I want to say it was probably 2017. So what are we at? We're at 8 years now that I've been with the university. So, just so you're aware, the reason that I am teaching this course is I manage a radiology department. I've worked as an MRI tech, I've worked as an X-ray tech, I've assisted in CT, I've assisted in ultrasound. I do manage a radiology department now. I've got X-ray, rad nursing. Um, I've got CT, MRI, ultrasound, nuclear medicine, radiation therapy, um, pretty much everything that we do in radiology. I've either done it or I've managed it. Now, the caveat to that is I have never done mammo. However, in a prior role, I was part of a team that would start up new MRI departments, and we started up a breast imaging center where we worked hand in hand with the mammo techs. So during the week where we cover mammography, if there's anything specific that you want to know, feel free ask, and I'll just have to reach out to one of my colleagues if I don't know it. So I believe this should not be a new environment for anyone. All of you guys are in the RT program and have taken online courses before. So you should be aware of how Canvas works. You'll see Canvas right here. You'll have your to-do list on the right-hand side. So what you guys should see in the announcement section is each week you'll see an announcement from me kind of covering what the next is. However, if we go back to the home and we scroll down, you'll be able to see. So week one is computed tomography. There's some PowerPoints for you to review, some different assignments that you can work on. And then you'll see for week one, you've got two different posts that you're going to make. So a welcome and introduction post. This is pretty much just telling the class who you are, what got you interested in radiology, a little bit about yourself, and then you're good. Don't worry about responding to any of your classmates. This is just a brief introduction of who you are. You probably had to do it for other classes. Feel free, go in, copy, paste. I don't mind, but it is nice for us to be able to get to know each other. And then the second thing that you're going to see is the week one discussion question. So for the discussion questions, these are going to be revolving around the topic of the week. So for CT, I believe the question is please list an advantage and a disadvantage of CT. So for CT, a great post is going to include talking about how CT's good at imaging the entire body when you don't have a complete history. So if a patient comes in unconscious or with impaired some type of impairment, you're able to do a high resolution image to look at the entire body to see if something's going on. However, disadvantage is going to be the high amount of radiation that the patient's going to be exposed to. So something like that, we're looking a good 1, 2 paragraphs explaining what we're looking at. The other thing that you need to do is you need to include a cited source, and you'll need to cite that source as well. This should be done in APA format, and I'll show you, we've got a little section above that will help you with any of your APA formatting questions. The live lecture, like I said, guys, so for the
Where you
live
going?
we are going to have it pretty much every Monday at 7:30, unless for some reason it says otherwise. Um, if you're on the live lecture, you do need to be present. At the end of the live lecture, I'll give you that code word, and the code word is what you're going to enter into the assignment. So I'll show you that right here. We click on it, go up to start assignment, go over to the text entry box, and you're going to type in code word, whatever the code word is for this week. You'll get some confetti and you'll be able to move on. However, like it says here, what you do need to do if you miss the live lecture, or say you start the live lecture and you get pulled away, and you do not get the code word. So it is very important that while you're here, you are listening. If you don't get the code word, you'll have to write a summary. It does say that it needs to be 2 pages. Some of the lectures are going to be a little longer than others. Some will be shorter than others. Typically, we're looking right around the half hour, 45-minute mark. None of them will go over an hour because I have another class that I teach at 8:30. So some of the summaries may be a little bit longer or shorter, but that's how you do that. And then you'll see each week, typically there's going to be an assignment. The assignments are open book. Use your textbook, get the highest grade possible. There are some assignments specifically in week 7 that have fill-in questions. They will mark them wrong if you don't do it verbatim. That's okay. I go in at the end of at the beginning of week 8, I manually grade all of them and you'll get your points. Without fail, I get a handful of emails after people start working on their week 7 stuff saying, I missed questions. I need you to grade that, take a look at it. Don't worry, I will. I manually grade them. Been doing it for 8 years now.
You just
And
call
then we've got
girl.
a week 1 quiz or a quiz each week.
Oh.
The quiz will be done through the Respondus lockdown browser. So you need to make sure that you have the Respondus lockdown browser downloaded. You're going to see this section here so exam proctoring information before you begin, and then a practice quiz. You do need to do these before you take your exam. This is going to make sure that everything's installed properly, that you're able to function and have the Respondus work properly for you. When you take it, it is closed book. Each week, you will see a study guide. Take a look at the study guide. Um, it's not going to, give you all the answers, but it will help you significantly when it comes to taking the quiz. So study the study guide. You get one shot to take the quiz. It is recorded. Um, and with that recording, just be mindful. It records everything, video and sound. So make sure that you're dressed appropriately. Make sure that you don't have a bunch of, background noises and things going on, dogs barking in the background, swearing about, how I'm the meanest professor you've ever had, anything like that. Just be mindful, view it as if you were in the classroom taking the exam. And then at the end of the quiz or at the end of the week, all of the quizzes will unlock for you to be able to look at them. However, you do need to sign into Respondus to be able to review that information. So week 1 through 7, each week is going to be a different modality. Week 8 is going to be a cumulative final. And for the final, you're going to want to take a look at all of your old quizzes, all of your old study guides before you take the final. Um, so before you guys reach out and you're like, I can't get access to it, you need to make sure that you're reloading it through Respondus. Okay, so before we get too far, let's jump into the syllabus real quick. So with the syllabus, y'all are adults. I don't need to read it verbatim. You can read it if you would like to. However, we will cover a few of the high points if it will load. There we go. So what the course is, this is subspecialty modalities, RAD 211. We are going to be looking at CT, MRI, mammography, nuclear medicine, radiation therapy, bone densitometry, PET scans, pretty much any of the different modalities that you can potentially go into once you have the foundation of being a X-ray tech. It is completely done over, online, so it is a distance education course. And then I've already pretty much covered how we're going to be assessing you. So we'll be doing those discussion boards. You'll post your initial post by Wednesday, and then you do need to respond to 2 of your classmates by Sunday each week. The textbook that we will be using is the Bontrager 10th edition. And then the way that we weight the course is 80% is going to be made up of your assignments and quizzes. Like I said, those assignments are open book, so make sure that you're using your text and using the resources at hand. Um, the quizzes are closed book, and then your discussion posts are obviously open book as well. So you've got 80% is going to be made up of your assignments and quizzes, 20% will be the discussion boards. Uh, for my late policy, I have it automatically built in that you can turn in anything up to 7 days late. However, it will automatically deduct points if you turn in things late. So if you turn it in 1 to 2 days late, it's a 5% deduction. 3 days to a week is 10% deduction. And then if it's over a week period, you better have reached out to me and let me know what's going on. At that point, if I approve it, say somebody gets sick or that you've got something going on, obviously we're going to make arrangements. We're going to work through it. However, if you don't talk to me, I have no way of knowing this. So if it's over 7 weeks or 7 days or 6 days past due, so at that 1 week mark, if I've approved it, you would receive a 20% reduction. Now, the grading scale is difficult, as all of your RT classes are. 100% to 94% will be an A, 93 to 87 is a B, and then 80 to 86 is a C. Anything more than that, you will be retaking the course. Unfortunately, every once in a while, I have a student that has to retake it. Um, it's not a lack of people not being able to understand the material or do the work. It's typically a lack of motivation. Most of the time, the students have multiple missing assignments, or I think I had a student the other mod that had 16 late assignments. So it's a matter of that people struggle with the coursework. If you stay up to date, do the work, this is not challenging. More so, it's for you guys to better understand what your future opportunities are. Plagiarism. Don't copy each other's work. Don't give out the weekly code. I can see everybody that signs into the course. I can see everybody that doesn't sign into the course. So if for some reason, say Ryan doesn't sign in, but he always has the code word, I'm going to start asking questions. So just be mindful of that. As far as plagiarism, I know there's some controversy out there of can you use ChatGPT? Can you not? As far as ChatGPT and I go, I'm okay with people using it as long as it is a tool for you to provide better work. It should not replace the work that you do. I view it kind of like a calculator, right? So if we're going to have tools at our disposal, you should be able to use them. However, don't just type it in and put it. I do run most of the things through AI uh, deciphers or whatever you want to call them. And if there's something that's more than 50% generated by an AI product, uh, I will be reaching out to you and we'll be having discussions about, how much of the work is actually your own. So, like I said, if you need it to help with an outline, I'm good with that. But if you're having it do your work, I'm not okay with it. Like I said, for Respondus, everything is recorded. Please be mindful of that. ADA statement. So if any of you guys have an approved disability or something that requires some type of accommodation, normally I'm made aware of it by now. If I've not reached out to you and you do have an ADA accommodation, please reach out to me and we'll get that figured out. And then like I said, the course work, you do have to get a C or better to move forward. Let me go back. So, few things that I like to kind of make everybody aware of. The course home is going to give you access to your technical support. There's not much that I can do as far as technical support for you guys. You will need to reach out to the Canvas team to be able to get for any help when it comes to the website or access. Student services, if any of you guys need additional help, have an issue that you need to work through, the Next Gen Student Assistant Program information could be found there. There is access to the online research library. However, most of the stuff you can use Google for. Just make sure that it is a scholarly article. If you pull off Jim Bean radiology.com, like that might not be the most or the best site to use. Most of the sites are Radipedia, Bontrager, any of the professional texts books that we use in our profession are absolutely fine. Any CDC or WHO article is absolutely fine as well. The virtual book can be found here. If you guys have a interest in knowing a little bit more about me, you'll find that under the welcome and intro. And then the APA style. If you have issues with APA, I'm not a huge stickler. I've gotten much more lenient over my years. But over the first week or two, if there's some minor errors, I'll reach out to you. We'll try to get those fixed. But if they do proceed on throughout the course, you will see some point deduction from it. And then tutoring information. If you guys need any assistance with tutoring, please let me know and I will point you in the right direction. Okay, last thing before we cover a little bit about what CT is. If you need to get a hold of me, inbox me. Right here is the inbox. I'm not going to click on it because I'm in the student environment. It'll just come up as an error, but you'll be able to write me an email. It'll come over to my phone or my email. I'll be able to respond back to you guys. I'd say typically I'll respond back within 24 to 48 hours. If there is an emergency, under the office hours section, I believe you will see my cell phone. Shoot me a text, let me know that you're one of my students and what you need help with, and I will be more than happy to help you. If you call me and it's an unknown number, chances are my spam blocker is going to block you, and I will have no way to know that you actually called. So just keep that in mind. Now, like I said, most of the live lectures are going to be 30 to 45 minutes of me going over a specific topic. So for this week, I've got a little YouTube video we'll watch. I think it's only 6 or 7 minutes, and then we will wrap it up after I give you guys an opportunity to ask any questions.
I'm wearing this top from Windsor.
And if you are not unmuted, if you can mute yourself, that would be awesome.
Cram. Welcome to another MedCram lecture. I want to give you a little bit of insight on CT scans of the chest. And this kind of brings up a point about high resolution versus just a regular CT scan of the chest. When do you order one versus the other? Let's talk about that. So if there was only one type of CT scan that you could get, and you were concerned that you had a lung nodule, what kind of CT scan would you get? Would you get a regular CT?
Sorry, guys, that is not what I wanted. This is the
A CT scan is an X-ray procedure that creates cross-sectional images with the help of computer processing. CT images are more detailed than conventional X-ray images and can reveal bones as well as soft tissue and organs. A conventional X-ray uses a fixed tube that sends X-rays in only one direction, while a CT scanner uses a motorized X-ray source that shoots narrow beams of X-rays as it rotates around the patient. There are special digital X-ray detectors located directly opposite the X-ray source. As the X-ray passes through the patient, they are picked up by the detectors and transmitted to a computer. Image slices can either be displayed individually in two-dimensional form or stacked together to generate a three-dimensional image that can reveal abnormal structures or help the physician plan and monitor treatments.
If you think about it, CT scans are really quite awesome. They allow you to see inside the human body without cutting it open. Like imagine if someone asked you to look inside a room, but not to open the door. That's effectively what a CT is doing. But the question is, how do they work? If we cut open a CT scanner, you can see that the inside is just an X-ray generator and detector spinning really fast in a circle. The X-rays travel through your body and get absorbed or scattered by your different body parts. This is called attenuation. You can think of it like how much the X-rays are being blocked from reaching the detector. Materials that are dense, like bone, have a high attenuation coefficient, so block more X-rays and appear white. Less dense materials, like your lungs, have a low attenuation coefficient, so let more X-rays pass through and appear black. So when you're looking at a radiograph, you're actually looking at a map of attenuation coefficients. The brightness of the pixel corresponds to the total attenuation of everything along the path of that X-ray. Now the aim of the CT scan is to reconstruct the values of those attenuation coefficients for the tissues that the X-ray beam passes through. It does this by shooting a narrow beam of X-rays to image a small slice of you at a time, and then stacking those slices at the end. We can simulate this with a 3x3 grid, representing a single slice of human tissue. Just imagine you have something like bone in the center of the image, which has a high attenuation coefficient of say 30, and everything around it is just empty space with an attenuation coefficient of 0. If we get an X-ray from this angle, we get total attenuations along these paths to be 0, 30, and 0. And this process is called forward projection. It's just taking a simple X-ray. We keep doing this forward projection for multiple different angles, and we get all these values. Now, say we didn't know what the values in the table were. How do we figure them out? Well, we do something called back projection, where we spread out the total numbers across the table. So we take the 30 and the zeros and spread it evenly across the row like this, and then do the same for all the other different angles. You can see how this creates a decent representation of our original image, where the center is a high attenuation and the edges have a relatively low attenuation. So it's a similar concept in CTs, except the image is 1024 pixels wide. Okay, so let's see this in practice. Say we have this image here. It's supposed to represent a brain that's been sliced axially. And just pretend that we don't know what the inside of this image looks like. So we need to put it through a CT scanner to find out. We take X-rays at multiple different angles and then spread out the result across the image using back projection like we explained earlier. As we collect more and more data from different angles, you can see that we get closer and closer to our original image. And bada bing, bada boom, we get a blurry image? Why is this? Well, back projection isn't 100% accurate, leading to some uncertainty in localizing the boundaries between different tissues. And you can see that earlier in our 3x3 grid. To understand why, we have to first understand that all images are actually just made up of waves of different frequencies. I found this really cool simulation on MATLAB. You can see how this image is being split up into a set of black and white sinusoidal waves like this, each with its own frequency. Splitting up an image or a signal into its constituent frequencies like this is called a Fourier transform. The Fourier transform is a super important mathematical function that pops up almost everywhere in physics and engineering. The most important takeaway from this is that the low frequency waves in our image gives us our large broad structures, and the high frequency waves gives us the edges and the finer details. Now let's get back to our CT image. The problem with back projection is that we oversample the low frequencies and we undersample the high frequencies, which results in a blurry image. So to get around this, we apply something called a high pass filter to our signal, which, as its name suggests, lets the high frequencies pass through and reduces the intensity of lower frequencies. And side note, the high pass filter is usually applied to the signal obtained at the detector way before the back projection step, just because it's faster and easier that way. So we do a back projection of these filtered signals, and bam, we get a sharper image which is pretty close to the original. And interestingly, when you edit a photo and increase its sharpness, your computer's doing a similar thing. It's performing a Fourier transform and applying a sort of high pass filter to the image. And if you're doing a Gaussian blur, then you're doing the opposite by applying some sort of low pass filter. This is all well and good, but there are actually better ways to create the CT image. It's called iterative reconstruction and is basically a guess and check method. Again, say we have this simplified slice of a brain which we're putting through a CT scanner and trying to reconstruct. In the first iteration, you start with a guess of what the final image looks like. This can be a decent guess made from back projection, or as simple as a blank image like in this case. The next step is to do a forward projection of our estimate at multiple different angles like before. But this time we stack all the different X-rays on top of each other to form something called a sinogram. You can see what I mean here. It's called a sinogram because it's forming these sine waves. Then you shoot X-rays through the actual patient in the CT scanner and get the measured sinogram. The aim is to get our estimate sinogram to look like our measured sinogram so that we can reconstruct what the inside of the patient looks like. We do this by dividing the measured sinogram by the estimated sinogram to form the ratio sinogram. The ratio sinogram is then back projected, and the result is multiplied with our initial estimate to form our new guess. Whew, so that's one iteration. And watch what happens with subsequent iterations. The idea is we get closer and closer to the true image until further iterations make no difference to our estimate. So what's the difference between this method and filtered back projection? Well, amazingly, this guess and check method produces higher quality images at the same radiation dose. You can see in this comparison here. The only downside is that iterative reconstruction takes a lot of computing power and time. So up until recently, filtered back projection was the industry standard. Now with modern computers, which are super fast and powerful, iterative reconstruction has become the norm. Okay, so we've done all this work, but we've only ended up with one slice of the human body. So we need to repeat this whole process for the rest of the slices in the body part you want to image. Then you can stack all those slices on top of each other and the radiologist can scroll through it. You can also do something called multiplanar reformation, meaning you can scroll through the images in different planes. You can also do
And if you ever hear a radiologist talking about it, they're going to call it MPR. So that's multiplanar imaging. And then another technique is a MIP, which is multi-image projection.
fancy 3D reconstructions, and you can even print out these 3D models. At its core, CT reconstruction is an inverse maths problem, meaning we have a set of observations and we try to define the factors that led to those observations. Inverse problems crop up in a lot of other places. For example, when you use a photo editing program and remove an object, the software is trying to solve an inverse problem by trying to figure out what was behind that object. And it all comes down to a bit of maths, which is why I find CT so fascinating. Sure, the maths you learnt at school seemed boring and pointless, but it's this math, things like algebra and calculus, which helps us look inside people without needing to cut them open.
Okay, guys. So that is pretty much it. Like I said, moving forward, Monday night, 7:30, be here. And each week we're going to be talking about a different modality, kind of focusing on that. So at this point, let me stop the recording and I'll give you guys your code word.
Recording stopped.
So the code word for week 1, I just want to know what you guys find the most interesting. What modality are you leaning towards without really knowing much about all of the different other modalities? So if you're interested in staying in X-ray, just put X-ray. If you're thinking about MRI, put MRI. If you want to be a mammo tech, put in mammo. So you'll enter that in through the assignment through Canvas, and you guys are good to go. So unless anyone has any questions, head on out. I'll see you this time next week. Thanks, Lauren. Thanks, Elizabeth. Thank you, Christy.